Algebra 1, Chapter 11, Section 3, Simplifying Rational Expressions. So, we've worked with things similar to this in the past when we were first learning about exponent rules. But something like m over v squared, or m times v squared over r is an example of a rational expression. Uh, Rational expressions can also have uh, polynomials in the numerator and the denominator. It doesn't have to just be monomials. The very important part, again, is always the denominator. Denominator cannot be zero. So when we're doing this, we always have to find um, the excluded values, and that's whenever the denominator is zero. And here I wrote fund. It should be find excluded values. Okay. So all I'm going to do with all of these rational expressions is identify the denominator. Here we have r squared minus 36, and I'm going to set it equal to 0, and I'm going to solve for r. Now you could factor this. I'm going to actually add 36 to both sides. R squared equals 36. Take the square root, and here's the important part. For this one, because we're not solving radical equations anymore, I do care about the positive and negative version of this. So r is positive and negative 6, which means the excluded values 6 and negative 6. For part B, same thing. Identify the denominator. N squared plus 4n minus 5 equals 0. And now we try to factor it. I need two numbers that multiply to be negative 5 and add to be positive 4. Well, how about positive 5 and negative 1? X plus 5, x minus 1 equals 0. And then we use the zero product property. X plus 5 equals 0, and x minus 1 equals 0. So x equals negative 5, x equals positive 1. So we'd say the excluded values are negative 5 and 1. Oh, I changed it to x. There, let me. That's just like a habit that people do after they've done so many of these things. I mean, you probably do it sometimes yourself. It's just a random habit to automatically make things the variables x, because that's what you're so used to. But um, that should be n, not x.